wonderful prayer. Wow, how are you guys feeling this morning? I was told you guys would be really tired. Are you tired? Yes? No? I hope that you're going to stay awake for this one because we have a fun challenge this morning. We began last night looking at the case, right? What did we look at? The case for what? Truth. Yeah. So we've kind of laid that building block down. And now that we've established that there is such a thing as truth, we're going to move forward and ask the question, is it true that God exists? All right, this is going to be fun, okay? So we're moving from truth to God, and then, of course, tonight we're going to look specifically at Jesus. It's going to be great. Got to come back for that. And then finally, we'll end off things by looking at the case for others. Now, I want to start with a true story that all begins on April 11th, 1970 at 2:13 p.m. Eastern Standard Time. Who can tell me the significance of that date? Who wants to take a guess? Did someone just say my birthday? Who thinks it's my birthday? Wow, that hurts. I was born in 1983, not 1970. Don't let the hair fool you, all right? Not cool. All right, no, not my birthday. Did someone yell Star Wars? Yeah, the Star Wars thing, the font there is just meant to throw you off. Okay, it's not Star Wars either. It actually has to do with a famous space mission. Did I hear Apollo? Someone just say Apollo? Yeah, this was actually the launch of the Apollo 13 spacecraft at 2:13 p.m. Eastern Standard Time, April 11th, 1970. Apollo 13 launches from Kennedy Space Center in Florida. This was the third scheduled mission to land on the moon. Now, initially, everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 2,000 miles per hour, that's as fast as a speeding bullet, the crew hears and experiences an explosion. And then you get Captain Jack Swigert famous words. You guys know them? Houston, we have a problem, and it was a huge problem. One of their oxygen tanks had exploded, and the other is leaking into space. Two of their three fuel cells is now dead, and the third is rapidly depleting. Apollo 13 has a new mission, and that's not to land on the moon. That's to bring those three astronauts home safely. And that they did despite limited power, loss of cabin heat, limited water. The Apollo 13 spacecraft actually landed back on Earth April 17th, so 6 days later. This mission was called a successful failure. A successful failure. Now, why am I telling you about Apollo 13? Well, just as the Apollo 13 crew survived against all odds in the lethal conditions of space, we too survive against all odds on this tiny planet that we call Earth. You could say that the conditions of the spacecraft were finely tuned to support life. And the slightest change in the conditions of that spacecraft put the lives of the astronauts in jeopardy. In a very similar way, we survive against all odds on this tiny planet we call, Earth. Okay, you guys are still awake. And the slightest change in these conditions puts our lives in jeopardy. Physicists say that this fine-tuning is balanced on a razor's edge. Think of a tightrope stretched across two skyscrapers. Literally, on either side of the tightrope, it does not support life, right? You take one step to the left or one step to the right, and you plummet to your death. In a similar way, the conditions are finely balanced. And we're going to look at the Earth. We're going to go up from the Earth, and we're going to look at the solar system. We're going to go out from the solar system and look at the galaxy. And then we're going to go out from the galaxy and look at the structure of the universe. How does that sound? Wow, like 4 of you are excited about that. We're just going to travel the universe in the next 30 minutes. Kind of wild. All right, here we go. Buckle up. How many of you guys have heard of Goldilocks and the 3 Bears? Okay, good. Well, you know how it works. One porridge is too hot, one is too cold, and one is just right. Well, in a very similar way, physicists have kind of picked up on this idea, and they say that our planet, Earth, is in just the right position in our solar system. It's not too hot, it's not too cold, it's just right. It's just the right distance to our planetary star, which we call the sun. Very good. So, if you could imagine, if we move the Earth further from the sun, you have a problem, it gets too cold. If you move the Earth too close to the sun, well, you end up too hot. I mean, where Mars is further out, it's like freezing at its equator in the summertime. If you were to go to Venus right now, well, it's like a little closer to the sun, and it's around 700 degrees Fahrenheit. Okay, so kind of hot, all right? Think of like your pizza oven, all right? Too warm to survive. But if you've been to Earth, it's beautiful this time of year. It is just right for life. Now, it's not just life. What we're talking about actually is liquid water, because what scientists have figured out is you need liquid water if you want life. That's how it works. No liquid water, no life. And so if you went too far out, you could get water that's frozen, so you get ice. If you get a little bit closer, you get water vapor. But Earth has all 3 states of water. It's really remarkable. In fact, our planet is 70% covered in water. Now, what you're looking at is the real miracle right there. That giant ice cube is floating. Everyone say, wow, right? That's pretty cool. Now, you probably never thought about this before. Water is so cool. I mean, it has a high specific heat capacity, so it takes a lot of energy to raise its temperature. It's why when you are on the driveway on a really hot day with your bare feet on, you could put a little water down and that spot stays cool, whereas the driveway heats up really quickly. Water dissolves a whole bunch of things, and that's really important about moving minerals around the planet. Part of the water cycle, really cool. But what you're looking at is awesome. See, when it comes to every known substance in the universe, this is what particle theory says. When the particles get colder, what happens to them? They get closer together. And so every known substance on the planet, natural occurring substance, when it goes from its liquid form to solid form, it actually gets more dense, except water. When water goes from its liquid to solid form, because of its molecular structure, it actually gets less dense, and that's why that giant ice cube is floating. And that's a good thing, because if ice were like every other known substance, it would sink to the bottom of lakes and oceans, and they would freeze from the bottom up, and you'd have a snowball Earth. Not good for life, all right? Now, you can try this at home, by the way. Take a glass, fill it with water, put some ice cubes in. If they don't float, you did something wrong, okay? You did something wrong. All right. But I can see you guys aren't impressed by that. Say, Tim, I'm not impressed by that. All right, we're going to see if we can impress you guys. You guys know the Earth is tilted? Yeah, you probably felt it when you walked in the room. You were like, whoa. No, you didn't do that. But the Earth is tilted. At what angle? It's like 23.5 degrees, okay? If it wasn't tilted, the poles would be extremely cold, and the equator would be extremely hot. Now, it is already pretty extreme temperatures, but it'd be much, much worse. The reason we have the seasons and our moderate temperatures is because the Earth is actually tilted at 23.5 degrees. Now, that is actually being held stable by our large moon. And thank God for our large moon, because if we didn't have our large moon, there would be no life on this planet. That's what the scientists believe. Okay, so it's about a quarter the size of the Earth. It's keeping our Earth tilt stable. Now, I can see you guys are impressed by that. Say, Tim, I'm not impressed by that. All right, how about this one? You guys know about the magnetic field? Yeah, there's like a giant bar magnet in the center of the Earth, and it produces like this magnetic field that actually protects us from dangerous cosmic particles and radiation coming from the sun. And so, I mean, watch this animation here. This took me all night, okay? Here we go. Look at those. Yeah, that's right. Do you guys want to see that again? Yeah. All right, let me back it up. Okay, let's just do that one more time. Oh, my goodness. What's really cool... Stop. No, keep going. Stop. Now, actually, if you've seen the Northern Lights, which is really cool, where I'm at in Canada, actually just like a month ago, it was really, the Northern Lights were like awesome. And what you're seeing is actually the particles being deflected to the poles and interacting with the atmosphere there, and that is the Northern Lights. And without that magnetic field, there would be no life. So every time you see those Northern Lights, think, man, that thing's keeping us alive. It is like a shield deflecting dangerous part. But I can see you guys aren't impressed by that. Say, Tim, I'm not impressed by that. Wow, you guys are not easily impressed. Okay, how about this? Let's go out to our solar system. Now, when I was in school, there were 9 planets. Believe it or not. I know. Those were the days. Now, you guys heard what happened to Pluto, right? Yeah, it became a dwarf planet. It got demoted. Boo. Yeah. Not cool. Now, most people don't know why. A lot of people think, oh, it's because it's so small. Small. That's why it got demoted. Actually, that's not it. It was discovered that Pluto's orbit actually crosses over Neptune's orbit. It's highly elliptical. And I don't know who gets to make this decision, but someone said if you haven't cleared your own orbit, you can't be a planet, okay? Yeah, I know. There's like a 3-hour debate online about whether Pluto should be a planet. It's absolutely riveting. So if you're having trouble sleeping tonight, you can throw that sucker on. Okay, so there's 8 planets, 4 terrestrial, those are the smaller rocky planets, and 4 gas giants, those are the outer planets. Now this setup is perfect for life. And I'll tell you why. Let's imagine there's an asteroid. And actually, let's do this together. Did I just lose my... All right. Oh, there we go. Let's all do this one together. Okay, everyone say, oh no. It's an asteroid headed straight. Wow, I was a little nervous there. I was feeling like maybe there is an asteroid heading straight for us. But we're not worried about that. I'll tell you why. These gas giants, they actually act like cosmic vacuum cleaners and suck in all kinds of space junk that protects us from being annihilated by space stuff like asteroids. It's really remarkable. And so if you look at Jupiter here, this is not to scale. Jupiter is huge. You could fit 1,300 Earths inside Jupiter. Its red spot is a hurricane, and it's 2 times the size of the Earth. That's a storm that's been going for a few hundred years. This thing literally just sucking up space garbage. We think like every month there's 5 massive impacts. You could see, actually, we have on telescope, as Jupiter travels, orbits the sun, there's all this like tail behind it of all this stuff just following it because of its gravitational pull. Awesome. Literally, when my kids were young, my oldest, who's 13 now, when she was like 4, I would talk about Jupiter because I taught in the public school system, and when I taught the solar system, this was in the textbook. The public school textbook. They said if Jupiter didn't exist, you wouldn't either. Pretty wild. And so every night, my daughter, when she was 4, would pray, thank you, God, for Jupiter. It was so sweet. Yeah, it was awesome. But I can see you guys aren't impressed by that. Say, Tim, I'm not impressed by that. Wow. Come on, guys. How about this? Let's go out from the Earth to the solar system, to the galaxy. You guys heard about our galaxy? So our galaxy is called the what? Because it tastes like chocolate. You know that in Canada we don't have the Milky Way chocolate bar? That is a crime. That is a crime. We have something called the Mars bar. It's similar, but it's not the same. It's not the same. Milky Way, it's because when you look out into the atmosphere, it almost looks, in the galaxy, it looks kind of milky from all the dust and gas. It's a spiral galaxy. It has these spiral arms. It's 100,000 light years across. If you're going to measure something that's really big, the yardstick ain't going to cut it. right? So what do they use? Well, how long does it take light to travel in 1 year? Turns out that's 6 trillion miles. And so 100,000 light years across, over 100 billion stars, like our sun is one of 100 billion in our galaxy. And we think there's over 100 billion galaxies in the universe. Kind of awesome. But what's really cool is where we live in this galaxy is just right. You don't want to be like near the center, because near the center, that's a black hole. A lot of radiation. Obviously, you don't want to get sucked into a black hole. There's super giant stars, which produce a lot of radiation. There's supernova. That's when a star explodes. And you do not want to be near one of those when it explodes. You don't want to be too far out in the galaxy either, because there's no heavy elements like carbon and oxygen and nitrogen. None of that stuff out there. Not good. You guys are thinking chemistry class would be so much easier. Yeah, but you wouldn't exist, okay? So you want to be between spiral arms. I mean, it's like a Goldilocks factor in where we exist in the galaxy. Awesome stuff. But I can see you guys aren't impressed by that either. You know what? It seems like our Earth and solar system and galaxy are fine-tuned for life. But the real fine-tuning that is causing atheists, agnostics, skeptics to sit up straight and take another look at this idea of God is what I'm about to show you. It is absolutely mind-boggling, okay? Now, here's what I need you guys to do. Imagine in the universe, there's a room, and it has all these dials, and these dials are set to certain values. Here's the thing. When you change the dials, you change the universe. And so if you want to change the speed of light, we just change one of those dials. You want to change gravity, change one of the dials. You want to change the mass of an electron, change a dial. And basically, you have all of these dials set just right. You change the dials, well, you change the universe. Here's the problem, though, when you change the dials. You go from a life-permitting universe to a life-prohibiting universe. A universe that will allow life to a universe that will not allow life. Have any of you guys ever tuned a radio before? Like, it's going to be all the old people in the room, okay? Like, they're used to, you know what I'm talking about. Like, you didn't just hit a button. You didn't just, select, you guys just hop, I want to hear this song, go on Spotify, play, you know? There was a time, though, you had to listen to the radio, and if you wanted to change your station, you had to find your station, okay? You had to tune the dial. And I want you to imagine that there's all these values that you could have the thing set to, but most of it's static. But eventually, you're going to get right into your station, your radio station. It's the same idea. This is what we're talking, fine-tuning. Now, here is what scientists who are not believers have to say about the fine-tuning, okay? Not believers. So here's Freeman Dyson. Now, he did not invent the vacuum cleaner, okay? He's a physicist, and I don't know why his pants are so high. Now, here's what he had to say. He says, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. Okay, that's fascinating. How about this one? Fred Hoyle. Now, Fred Hoyle was an atheist and actually came to believe in God based on some scientific evidence. Really wild stuff. But he says this, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seems to be so overwhelming as to put this conclusion almost beyond question. That's pretty cool. Check out this last one, George Greenstein. He said this, as we survey all the evidence, and I'm going to show you just a couple, the thought insistently arises that some supernatural agency, or rather, capital A, agency, must be involved. Two questions here. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? The answer is yes. Was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is, check this out. I'm going to give you two examples of what they're talking about. One has to do with the mass of particles, and the other is going to have to do with one of the forces called the force of gravity, okay? Now, stay with me, okay? We're going to keep this so you guys can understand. I'm telling you, this is the only convention you are ever going to go to where they're going to talk about quark particles, okay? I'm just saying, but it's going to be fun. Underlying all of material existence, whether we're talking about bees or computers or peoples or stars or planets, whatever, is the simplicity of a few particles, okay? Now, there was a time when they thought the atom was the smallest particle, right? Atom was it. And then they broke the atom. And they found that there were these subatomic particles, electrons, protons, neutrons. And from those 3 particles, you could make up the entire periodic table. Now, I should have gave a trigger warning, okay? There's chemistry. There's a whole periodic table, and you could literally, from just those particles, build this whole thing, any element on there, okay? So you want to make helium? Just take 2 protons, just take 2 neutrons, take 2 electrons, boom, you got an atom, okay? A helium atom. Very, very cool. And scientists thought, that's it. We have kind of cracked the code. And then they started smashing these particles together in these huge particle accelerators. This is really cool stuff. They spent billions of dollars building these things. And what they found was you can actually break these things. You can actually break the neutron and the proton into smaller particles that they call quark particles. Everyone say quarks. Yeah, maybe you've never said that word before, okay? And it said, and they didn't get too creative with the names, but 1 up quark and 2 down quarks makes a neutron. And 2 up quarks and 1 down quark makes a proton. And we have been trying, or I haven't, but they have been trying to smash the electron, and it seems like it can't be broken. So these look like the most fundamental particles in the universe, okay? And they are very, very small. Like when you look at the person next to you, they are made of this stuff, okay? Now, the mass of these particles is ridiculously small. I just want to wow you with all these zeros, okay? Now, I apologize that this is in kilograms. That's the metric system. And by the way, that's what everyone uses in the world, okay, except you guys. It is like the standard for measurements. But if you want to do your own thing, fair enough, all right? Now, but it's my talk, so I get to do what I want. So here's the mass of the down quark. Now, I want you to imagine that we change this thing by the slightest amount. The slightest amount. Increase it by a factor of 3. This is where things get wild. If you were to change the mass of the up quark by a factor of 3, all of chemistry basically disappears. And all you're left with is a universe that just has hydrogen. That's it. That is a lifeless universe. That's a universe with no planets, and no stars, and no galaxies. None of the stuff we just looked at. No elements besides hydrogen. But if we were to, that was a down quark. If we were to change the mass of the up quark by a factor of 6, it's even worse. You'd have no chemistry. The only thing you have left is neutrons floating around. Is that a universe with life? Of course not. You could never have any kind of material life in a planet, in a universe like that. And the same thing with the electron. If you were to increase the electron by a factor of 2.5, scientists have figured out that, man, you have just a neutron universe. This is bad news. This is a lifeless. This is a fine-tuning. This is why they say, man, it's like the universe knew we were coming. It's like a super intellect has monkeyed with physics. Now, I want to talk about gravity here for a second. So that was one of the masses of a fundamental particle. Let's look at some forces for a second. Well, just one, the force of gravity. And you all understand gravity. It's easy to talk about because it's what's holding you in your seat right now. It's the reason you're not floating around. Every 2 objects in the universe are gravitationally attracted to each other. In fact, I use this as a pickup line on my wife in university. Do you guys want to hear about that? Because we can just move on. No, you want to hear about that? Okay, you want to hear about that? So we're in the library at York University. This is near Toronto. And I was studying physics. My wife was studying chemistry. And there was chemistry, all right? There was chemistry. And we got introduced to each other. And I said to her, you know you're attracted to me, right? And she said, excuse me? And I said, gravitationally. It's a physical attraction. Now, and she ended up marrying me, so that's kind of cool. So some of you guys, I know you weren't taking notes up until now, but you might want to write that one down, okay? Actually, turn to your neighbor and say, you know you're attracted to me? Gravitationally. All right, some of you guys are really like, this is my opportunity. This is my opportunity. All right. It turns out the force of gravity, that constant big G on the screen, is finely tuned to 1 part in 10 to the 40th power. That is a 1 followed by 40 zeros. Now, your mind actually cannot get around these numbers. Like the odds of you being hit by lightning are 1 in a million. That's the orange on there. The odds of you winning the lottery, at least in Canada, is like 1 in 100 million. Okay, I don't know what it is here, but it's 1 in 100 million. The odds of being struck by lightning and surviving, and then being struck by lightning again, like twice in your lifetime, is 1 in a trillion. But the odds of getting a life-permitting gravitational constant is 1 followed by all those zeros. Now, let me give you an illustration to help you wrap your mind around this. Imagine we take some Canadian dimes, which are not worth very much here, okay? Yes, they have sailboats. And we cover the entire continent of North America. The entire continent of North America. Say, that's a lot of dimes. That is a lot of dimes. I literally copied and pasted all those on there. That is an afternoon I will never get back, okay? I'm just saying. Now, then we take those dimes, so cover the entire continent of North America, and then we're going to stack those all the way to the moon. Okay, say, that's a lot of dimes. That is a lot of dimes, okay? That's why I gave up. You guys get the idea, though. That's all of them stacked up to the moon. And then we do that on 1 billion more continents. 1 billion more continents. All stacked up with dimes. And then I take one of those dimes and I paint it red. And I throw it into the sea of dimes on 1 billion continents stacked to the moon. And then I blindfold you. And I say, pick the red one or you're dead. The chances of you picking the red dime from the sea of dimes on 1 billion continents is around 1 part in 10 to the 40th power. Now here's the thing. If you picked the red dime, you know what people would conclude? They'd say, you cheated, you peeked, you saw through the blindfold, you designed the outcome. You would conclude design. And that is why people who are looking at the fine-tuning of the universe, just taking out their telescopes and seeing what's going on, are able to say, man, this looks like design. A fine-tuned universe looks like it has a fine-tuner. Now, actually, I want to show, and I actually told the guys I wouldn't have a video, but I actually do have a video. I know we're hooked up here. I'm hoping this is going to play. This reminds me of a clip from a famous movie. I'm not recommending the movie, but I'll just tell you, you have Lloyd Christmas, and he meets this woman, Mary, at the beginning of the movie, and he spends the rest of it, he falls in love with her. It's like love at first sight, and he travels the country to reunite with Mary, and at the end, he asks the question, what are the chances of us being together? What are the chances? And here's Mary's response.
What are my chances?
Not good.
You mean good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance? Yeah!
No, Lloyd, she's saying you don't have a chance, right? Maybe she should have said 1 part in 10 to the 40th power, right? Maybe that would have kind of got the message across. That's the thing. Some people conclude, well, strange things happen. Maybe it'll happen eventually. Probabilistically, though, reasonably, not likely. And by the way, the gravitational constant is just one particular constant. There's a whole bunch of others. The cosmological constant. This is a weird one. We're not going to get into it. But gravity pulls everything together. Well, there's a force actually blowing everything apart that kind of balances gravity. And scientists call it dark energy. They think they're in the dark. They don't know what it is. But they talk about it as the cosmological constant. It's fine-tuned to 1 part in 10 to the 120th power. There is so many zeros in here, like we can't even wrap our minds around this. There are only 10 to the 80th power of particles in the universe, okay? Like these numbers start to break your brain. That is how wild this is. What's really interesting is you have these scientists who are looking at this, and it's pointing them towards God. It's pointing towards God. Robert Jastrow wrote a famous book called God and the Astronomers. He's an agnostic astronomer. Agnostic just means he didn't know whether God was real or not. But here's what he had to say. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak, and as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Because what have theologians been saying for centuries? That 20th and 21st century scientists are just starting to understand. Well, in the beginning, God created the heavens and the earth. This is where science points. If anyone ever tells you that science and faith are incompatible, they don't know what they're talking about. When I was in university and struggling with my faith, struggling with my doubts, studying physics at a secular university, it was studying the evidence, the scientific evidence that pointed me toward God, not away from God. And this is just one of those examples. Is it any wonder that Paul, writing the book of Romans, definitely not understanding all the stuff we just talked about, but still was able to pen these words. For the invisible attributes, namely his eternal power and divine nature, speaking about God, have been clearly perceived ever since the creation of the world in the things that have been made, so they are without excuse. Worship team, you guys can come on up. Notice, we can open up our Bibles, and we're going to do that tonight, all right? And we're going to look specifically at who this creator is, okay? But you can gain information about the creator of the universe just by looking at what he has made. That's what the text says. What can you know? You can know about his power. Man, it takes something very powerful to create everything we just looked at. We can know something about his divine nature. Yeah, there is something beyond the universe that had to create this. Something beyond time, beyond space, beyond matter, beyond energy. So that people are without excuse. What's fascinating is, in the beginning, God created. And then you go to the New Testament, and you get these words from John. And John is meant to echo what was stated in Genesis 1. In the beginning was the Word, and the Word was with God, and the Word was God. Okay, so the God at the beginning, that's the same God we're talking about. Okay, you jump down to verse 3. What's it say? All things were made through him, and without him was not anything made that was made. Okay, So we're talking about the same God in Genesis who made the heavens and the earth. He's the creator. He made everything that's made. And then you get to one of my favorite verses in the entire Bible, okay? John 1:14 says this, "And the Word became flesh and dwelt among us." Okay, this is interesting. The God that we just learned about, who created the universe, is the same God who comes to this earth, this finely tuned earth, in this galaxy, in this solar system, on this earth, and takes on human flesh. In a way, we've been talking about Jesus this entire time. That's what the text says. We've been talking about the Creator. We've been talking about Jesus. Every fine-tuned, precise condition, those were all really cool. But the coolest thing of all is that Creator who made this, we aren't just like an ant farm or a hamster cage and this really cool thing that's created and just, no, God has actually come to us on a rescue mission to seek and to save that which was lost. In fact, the Creator that made all that actually died on a cross for you. And tonight we're going to go into a lot of detail on that. Pray with me. Father, thank you that you have revealed yourself not just in your word, but in your world, that your fingerprints are all over this creation and that we are without excuse. And so, God, I pray that the students here would actually come to know you in a deeper way. They would leave this session with their faith strengthened in who you are, wanting to know you more, wanting to pursue you as Creator, but not just as Creator, but as Savior of humanity. God, we love you. Accept our worship. In your name we pray. Amen.